Now here we have the set of three problems: 11.12, 11.13 and 11.14. Hydrogen sulfide is removed from the coal gas by contact with a moving bed of iron oxide particles, which convert to sulfide as follows. So this Fe2O3 converted to FeS. In our reactor, the fraction of oxide converted in any particle is determined by its residence time T. The fraction of oxide converted in any particle is determined by residence time and the time needed for complete conversion of the particle, that is tau. So residence time is T and time required for the conversion of complete particle is tau, and this is non-ideal system. So T, when T is less than 1 hour and tau is equal to 1 hour, that is time required for complete conversion is 1 hour, and this is values less than 1 hour. So 1 minus x is equal to 1 minus t by tau cube. Now this particular expression or this concept, this has been taken to demonstrate the residence time distribution studies application in these reactors. So it is just for introduction. This expression or such many expressions we will be deriving in the next semester for gas solid reactions. So now we just accept it as it is. You can refer to the video lectures on gas solid reactions in chemical reaction engine 2 lecture series that is already available on YouTube. So this expression will derive then. Now we take it as it is. It is given XA is equal to 1 when T is greater than or equal to 1 hour, because time required for complete conversion is 1 hour. So if the time spent in the reaction is more than 1 hour, in the reactor is more than 1 hour, conversion will be complete. Okay. With this information, find the conversion of iron oxide to sulfide if residence time distribution of solids in the contactor is approximated by the curves shown against these three problems. So different kind of curves we have to deal with. So this is the setup: coal gas with hydrogen sulfide, here oxide entering, here coal gas without H2S, so you are removing H2S gas, and here you get the solids out. So hydrogen sulfide is removed in an, so this particular reaction, okay. So these things we'll be studying in much more detail, and that model we are using as the final expression is given. We will study this in details and derive the expression. First problem 11.2. E curve, this is 1 hour. Area under the curve is 1. So this value will be also 1 hour inverse. 1 minus x is t, 1 minus t by tau whole cube. This is known when t is less than 1 hour. For t greater than 1, xa will be 1. Now this is for the particles, and we have lot of particles, and there is a distribution of different sizes of particles, and that will get into finally the exit edge distribution. Exit edge will be different for that, and that exit edge distribution given by E, that is exit edge. We have to integrate this 1 minus x, this 1 minus x into E dt to get 1 minus x bar. Okay, this is the same thing as we have done. Ca bar by Ca0 is equal to Ca by Ca0 into E dt. 0 to infinity, complete range, whatever. So this 1 minus x bar is nothing but 1 minus Ca bar by Ca0. and that is Ca by Ca0. Okay. So 1 minus x bar mean conversion between 0 to 1. 0 to 1. Your normalized distribution, we say 0 to infinity, some high value. 1 minus x. Now this 1 minus x is given as 1 minus t by tau in terms of this dimensionless variable. Okay. Tau is 1. So this is simply 1 minus t whole cube. E 1 into 1 is area should be 1. So this is also 1. So you solve this, you get it as 0.25. So x bar is 1 minus 0.25 and that is equal to 0.75. So you get mean conversion as 75%. Next, 11.30. So here we have direct delta function. Same thing. So this is infinity, high value with area is equal to 1. So del t minus t0 is defined. This t0 and our case t0 is 0.5. So t0 is 0.5. It is in hours. Tau is given in 1 as 1 hour. Xa is equal to 1 when this t is greater than or equal to 1 hour. That way. So again 1 minus x is 1 minus t by tau whole cube for t less than 1 hour. 1 minus x bar will be 1 minus x into e dt. So 1 minus x is 1 minus t by tau whole cube and e now is del t minus t0. That is your direct delta function. And for this, solution of this integral will be simply f of t0. Okay. T0 is 0.5. So f of 0.5, that is half. Our function is 1 minus t by tau. Tau is 1. So 1 minus t whole cube. So if you substitute this as 0.5, you get f of t0 as 0.125 and x bar will be 1 minus 0.125, that is 0.875. So mean conversion will be 87.5% for this case. 11.14. Now E curve, this is given from 0.5 to 1.5. Okay. So this is 1. 1 minus x, same thing, 1 minus t by tau whole cube when t is less than 1 hour. 1 minus x bar is 1 minus x into e dt. This tau is 1, so 1 minus t whole cube. This is again 1 because 0.5 1.5 minus 0.5 is 1. This area should be 1. So this value must be 1 hour inverse. So that we have substituted. Okay. So finally, this you get as 0 when you substitute the limits of integration. That means mean conversion will be 100% now. Okay. Mean fractional conversion is 1. So 100% conversion in this case. You can compare all the three cases.